How's it going, everybody? In this lecture, we're going to be talking about all things kind of configuration and configuring applications in Kubernetes. Now, the first thing I'm going to mention is how you configure an application varies quite a bit depending on how that application wants to be configured. We're not going to be talking about how to update our particular applications to be configured. And what I mean by that is actually writing the source code and kind of configuration injection points. But what we're going to talk about is how we can use the mechanisms in Kubernetes to provide files or environment variables or that kind of stuff into applications, so that if an application can be configured using files or environment variables, that you know how to do so. And especially in the hands-on that accompanies this lecture, it should help out by solidifying a lot of those different pieces. So with that, here's our goals and outline for today. I'm going to start off by talking a little bit about 12-factor applications, because that helps sets the stage for a lot of configuration and how a lot of application developers think about configuring their applications, especially in a cloud-native environment. We're going to talk about the concepts of configuration and using environment variables and files and that kind of stuff, because those are very specific to containerized workloads. Then we'll dive into what that looks like in Kubernetes. So using environment variables for our pods, as well as using ConfigMaps and secrets. So quite a bit, but it should go through fairly quickly here. So let's start off first, talking about the intro to the 12-factor app. Now, I love starting off with this slide because the industry is moving very much towards building cloud native applications. And usually when people think of cloud native, that means, okay, I need to deploy to the cloud and use things like AWS or Azure or Google Cloud or whatever. And I need to leverage all those services and everything. But this quote came from a website from a company called Pivotal. And I don't think this quote's available on their site anymore, but I still use it because I actually really love it. Cloud native is about how applications are created and deployed, not where. And so the whole idea of cloud native is to build our applications so that, kind of going back to one of the original mottos of Docker, build once, run anywhere. How do we take this app and build it once, but run it in on my local machine or in a Kubernetes cluster or in the cloud or whatever? How do I build once and run it anywhere, but just kind of swap out configuration for those different areas based on how it needs to run? Okay, so that's really kind of the idea of cloud native. How do I make my app flexible? Okay, so a little bit of background on the 12-factor app, so we understand where this is coming from. So if you're not familiar with Heroku is a platform as a service company. It was founded in 2009, and it currently supports, you can write apps and lots of different things. And what's really cool about it is you can write code, push it to a repository, and then it automatically builds it and deploys it. And it's super slick. Super awesome stuff. But as they were getting started, they realized, there's not a lot of expertise in this space of how do we make apps that can be deployed to different environments and whatnot. So some of their co-founders and developers kind of got together and said, we're going to build something that we're calling 12-factor. And 12-factor, not a 12-factor login, but 12 different principles, 12 factors that make cloud native applications and applications that are flexible. And again, this is based on their experience of deploying thousands of applications or hundreds or thousands or however many across the Heroku platform. And they presented it in 2011. Okay, and you can go to 12factor.net and see the full list and the details, and it goes into it quite a bit. But at a high level, here are the 12 principles. So code base, dependencies, config, backing service, build, release, run, processes, etc. So there's 12 different areas to look at, and how do I manage my logs for my application? How do I do my database migrations or admin processes? And they've got opinions on how to do these different things. And many of these concepts are still very true today. And in fact, the containers took a lot of these concepts and kind of baked them into how containers run, especially the Docker runtime and whatnot. So it wouldn't be a bad idea to dive further into this. We're not going to get too much into it during this course, but especially if you're wanting to do development in this space, it would be worth looking at and having having some experience and kind of understanding of what is it that they're trying to do here. And as always, if you've got questions about any of these particular pieces as you read through it, let me know. Be happy to explain. So let's talk about one of those specific points. Okay, so config, which is factor number 3 for them. And it says store config in the environment. Okay, an app's config is everything that is likely to vary between deploys. So whether a staging production development environment or local on your machine versus in the cloud, whatever. This includes resource handles to the database, to Memcache, which is a caching service, other backing services, credentials to other services such as S3 or Twitter or any other API keys, as well as pre-deploy values such as what host name. If I'm going to do redirects, what host name am I using? Apps sometimes can store their config as constants in the code, and honestly, we have a lot of that happening here on campus. Where here's the dev config, here's the pre-prod config, here's the prod config, and then when I start up, I just kind of switch between what config I'm using. But it says this is a violation of 12-factor, which requires the strict separation of code of config from code. Config varies substantially across deploys. Code does not. So again, you want to think about what are the things that are going to change between the deploys, and I want to extract that as configuration. I don't allow myself the ability somehow, some way to change that across deployments. And this final point, a litmus test for whether an app has all config correctly factored out of the code is whether the code base can be made public or made open source at any moment without compromising any credentials. And so, yeah, if you have any secrets baked into your code base, well, then you're in violation of this. Okay, and no big deal if that's the case for any of your apps right now. Got to start somewhere, and you can always iterate to make it better. So storing config in the environment, like it said, how do we do that? What mechanisms exist in the environment for us to do that? Now, container orchestration frameworks make it a lot easier because they, again, are kind of build with this configuration, this configurability in mind. And so they do their best to make these easy. So the first off is environment variables. And in case you're not familiar with environment variables, we'll see some examples of this in just a few minutes. They're variables that are defined in the environment and just simply passed to running processes. They can be overridden or changed at runtime. So I can start a container and specify environment variables, and they're just variables that exist in the environment. And we'll see an example of a node script that can use them. Files configuration can also be passed along in files. So for example, YAML is used a lot in the cloud native space. I can provide a YAML document that has a bunch of configuration and make that available to the container. It can load that YAML document and then configure itself to make adjustments or whatever from there. Okay. All right, so let's talk environment variables. Okay, so environment variables, again, are passed along from a parent process to a child process. And all processes by default inherit the environment of its parent. And most languages and frameworks provide access to the environment variable. So let me grab the laser pointer here. On the left here, I just have a very simple node script that says hello message. And then this is reading from process.env. So the process environment variable named message. When I run this, when I export a environment variable, so export makes that environment variable, it's not going to use it just for the local one, but it will export it to additional processes that it starts. When I run node, well, now it's replacing this process.env.message now with greetings. Okay. And so it allows me to say, well, I'm going to use this single node script, and I can simply swap out the value of message, what that environment variable says, and now I can change the way that this application runs. Now, of course, this is just doing a console log statement. It's just printing out some data. But I could have this be a flag of some sort. If the flag is true, run this code versus that code or whatever. Or maybe it's log levels. Do I want to see the debug log statements or the tracer? There's just so many different types of environment variables that could be made available. Okay. Now, I guess the last thing I should say here real quick too, and I mentioned this earlier, is that I'm not going to be talking about how do we write code to make use of environment variables or files or whatnot. So again, if you're picking up an application kind of off the shelf and you're running it, you'll have to look through their documentation and see how do they want their app to be configured. And if you are writing code, well, you may want to think about, well, what are the things that are going to change? And all right, how do I get access to environment variables, or how do I want my own application to be configured? Okay. Um, so important things to think about: when to use or not use environment variables. Okay, environment variables are completely fine for kind of changing options or feature flags or anything of that sort, or providing pointers for files. We'll see examples of that here in a minute. Really configuring any non-secret data. Okay, they should never be used for any secret data. And the reason why is because environment variables are just leaked far too often. Okay. And you know, you're like, okay, leaked where? Debug info, they can be leaked to third party. There's a lot of frameworks that might use or integrate with third party services. So like when an error happens, it can collect information about the environment and send it off to this third party tool. And then you can use it to kind of track what errors am I seeing, or what users are triggering them, and help you kind of triage and fix bugs. But you obviously don't want to send off environment variables that might contain database secrets or stuff like that. So actually, just as an example here, I'm going to switch over to my terminal here, and I've got an index.php file that just runs PHP info. And if you're not familiar with PHP, don't even worry about it. But what I'm going to do is I'm going to do a Docker run, and I'm going to mount the current directory to the web root, and let's run PHP Apache. And so, okay, I don't have the image download, so this will take just a second. But so what I'm going to do is I'm going to run PHP, and this PHP info screen is basically a huge debug output of the web configuration. And there's a lot of systems that a lot of frameworks. I don't know if WordPress still has it, but for quite a long time, you could go to a page and kind of see, here's the server information, the server config, and it would include all the environment variables and everything else. So again, you just want to be really careful with how you use this. Okay, so this is almost done downloading here. And I know I'm just doing this directly with a Docker run, and we haven't talked too much about using the Docker CLI in this class, but you can kind of think of this as the same thing as I'm doing just a kubectl run. All right, so what I'm going to do is I'm going to go split screen here. Actually, let's just open up another tab here. And so I'm going to, it might have helped if I expose the port. So let's run that again. Let's go to 8080, and I'm going to specify db secret equals test. Okay. Now, so if I curl localhost 8080, I'm going to get a ton of stuff here, because the PHP info gives you just so much information about all the modules and time zones and just a ton of stuff. Okay. Now, so if I look for this environment variable name db secret, I'll see that it's output here. So env db secret and the value of test. Okay, and it's actually out here twice. Once as a variable, and then kind of there's two different ways that environment variables can be made available in PHP. But anyways, so I see the db secret test here. So again, if I actually had an application that was using environment variables as secrets, there are ways that those can be made available fairly easily. Okay. So again, you just want to be careful in how you think about them, how you use environment variables. And we'll talk about ways to actually store secret data. And well, now we'll talk about it. So the way to store secret data, as well as a lot of just other configuration that might be a little bit more lengthy or more complex, is using files. Okay. If it's a file, we remove the possibility that it's going to be leaked in any environment variable dump. And so now to be compromised, somebody would actually need to get file system access. And that raises the barrier quite a bit here. And the idea being is that the application can read a file and then load its, load the properties or the configuration, whatever it is, and use that to configure itself. Okay. Now, so this does require, as this bullet point says, an understanding of the file structure and schema. So, if my application is expecting JSON as its configuration, well, I need to know what keys I can put in the JSON file to configure my application. And So that does kind of mean if you're writing an application that others may be able to reconfigure, make sure you write good documentation so that others can know how to configure your app. Okay. And this is just an example, again, another node-based example in which when I first run this, I just get index.js. And what's happening here is this is saying this is a function of git config. And if there is a environment variable named config file path, I'm going to load that. In this case, it's going to be a JSON file. I'm going to load that, and then whatever that is in that file is the configuration for my application. Otherwise, I'm just returning a default set of configuration, in this case, db_hostname. And so this file is going to call git config and then output the db hostname. So in this case, again, the default is just Mongo, and so I see Mongo. And now I'm going to create a JSON file that changes that, and so it specifies the db hostname of example.com, store that to a file named config.json, and then I export the environment variable that it's looking for, config file path. Now when I run it, I get a different value for db hostname to be example.com. And so this is just a really simple example of, right now I can run an application and I can, one, give it a file, but then also, in this case, I'm using an environment variable that kind of serves as a pointer to where is my config file found. And the app reads that config file, configures itself, and goes. Now, so again, this is a really simplistic example, but when you run applications, especially in Kubernetes, most applications can or should have some way to configure them. And it's going to be kind of up to you or whoever's deploying the application to kind of understand how can this thing be configured. And if not, how can we get it so it can be configured? Okay. So let's talk about environment variables and pods. And before I do so, I'm going to get a quick drink. All right. So defining environment variables and pods is pretty simple. In the pod specification, I just use the env key, and then I can give an array of name value pairs. And so this is saying, okay, I'm going to define a environment variable option A, give it the value of ice cream, option B of brownies. And actually the voting app that we use on the hands-on 2 weeks ago, if you specify option A and option B, you can override the voting choices in the voting app. So you may want to give that a try if you want to. So again, you can define as many as you want, and we actually have some apps here on campus that have almost 50, maybe more than 50 environment variables. Honestly, I think that's way too many configuration points, at least to be all environment variables. It probably makes sense to turn that into a YAML document or something. But anyways, you can define as many as you want here. Okay. And one of the other cool things that you can do with environment variables is you can actually kind of expose runtime information to the application itself. So for example, if the app needed to know what its pod host name was, or maybe what node it's running on, or there's a variety of other things, you can use this value from, and then there's a field ref and a field path. And so this is pulling from the pod, the metadata.name. So in this case, when I run this pod name would have the value of app. Again, there's a lot of different things you can find. You can look at the Kubernetes documentation on other supported fields and things that you can put there. For the most part, though, I've very rarely needed to use this. Examples might be, pods that are scraping logs and going to send the logs off somewhere else. It needs to know, okay, what node am I running on, so that I can put that as extra metadata or whatnot. But for the most part, I've never really had to provide runtime configuration to my application. Okay. So environment variables is super simple. You'll get lots of practice with the hands-on, so I'm not going to spend too much time with those. Okay. Config maps and secrets take a little bit of understanding, and we'll start with that. So defining using config maps. Okay. So a config map provides the ability to store non-confidential data. Okay. And it's important to remember that. So config map is just configuration. It's not secret data. And the data is stored as key value pairs. And this example here that I have on this slide actually comes from the Kubernetes documentation. And what we see here is I've got a config map. It's named game demo. And I see two different, more or less, types of data that's being stored here. So again, under data, it's just key value pairs. These are more property-like, where it's just key value, key value. But then these are a little bit more file-like. At the end of the day, they're still just key value, but they're a little bit more file-like. And so these are, there's a key name game.properties. Again, it's just a key name. And the value, if you use the pipe and YAML, it allows you to have a multi-line value. Okay, and then it will preserve all the new lines. So game.properties will have these 2 lines as its contents. Okay, and same thing for user interface.properties. Now again, at the end of the day, it's just a key value map. Okay, these aren't creating files anywhere or doing anything, and you don't have to name it .properties or anything like that. At the end of the day, when I create this config map, my config map will have 4 keys to it: player initial lives, UI properties, file name, game.properties, and user interface properties. That's it. Okay. What you do with that config map is kind of up to you. And there's a couple different ways that you can use a config map. Okay, so the first thing that you can do is you can actually use a config map to populate the values of environment variables. Okay, and so earlier, let me jump back a couple slides here. We had env name and just value. Okay, and then we had value from a field reference. Well, in this example now, we've got a value from, but now we're doing a config map key ref, which I know is a mouthful there. Okay, so what we're saying is that the value for this player initial lives environment variable is actually going to come from a config map. And the config map that we want to pull from is called game demo, and the key is player initial lives. Okay, and same thing for this other environment variables. I have a UI properties file name, and then a value of coming from the config map. Now, if we actually wanted to, let's do a quick little demo here. I'm going to apply that same config map that I have in the slides. And so it's created it, and let's just take a look at it. So I can get the config map, and if I export it as a YAML, I'll see basically the exact same thing. But you'll notice here that it's actually, instead of doing the pipe kind of syntax we were seeing in the slides, it's actually keeping the /n, which is the new line character. And so there's my config map. I can do the same thing if I just get config maps. It'll tell me how many data properties are on that. So there's 4 keys on that config map. Yeah, I don't think there's really anything interesting to see in a describe for a config map, but let's take a look. Okay, so yeah, you can see the output, and it just puts it a little bit neater to see. Maybe neater? I don't know. It's still a little messy. All right, so now let's actually apply the config map, and I'm going to do it through the environment variable. And in case you forgot what that looks like, we'll bring that up here. So this is just going to run Alpine, and it was just a pretty empty container. And I'm going to run the env command, which just dumps all the environment variables to the logs. Okay, so if I run kubectl logs config map demo pod environment, here are all the environment variables that were defined in the pod, and you'll see that okay, the 2 that we defined in our pod spec are there, as well as some other ones, and a lot of these are others just come default with a container. So the Kubernetes information, how to find the Kubernetes API, that kind of stuff, and so again, it's providing some default config for us as well. All right. So the other way to use config maps is actually we can create files from them. And this kind of goes back to the configuration as files idea that we were talking about earlier. Again, some applications may want the configuration presented as files. And so the way to think about this is when I start a container, the file system for that container is coming from the image. Okay, that snapshot of the file system. But I can use volumes to kind of augment and kind of layer additional things on top of that file system before the container actually starts. So in this case, what I'm doing is I'm creating a volume named config, which is going to be populated by a config map. Okay, so again, kind of think of this volume as you can almost think of it like a USB drive. Okay, I'm going to create a USB drive here, and in that USB drive, I'm going to put a file named game.properties, in which the contents of that file comes from the key game.properties in the config map. Okay, and same thing for this other file. So in my little USB drive, I'm going to create a file named user interface.properties in which the contents of that file come from this key in the config map. Okay. So by defining this volume, I'm more or less, again, kind of thinking of it, I've created a USB drive. Okay. And it's not until I mount that it's now going to be in the container. So again, going back to the container, I've got this container image or this container file system that's running. And now I'm going to take that USB drive and I'm going to plug it into the container, and it's going to be available to the container at /config. And that's where the app is going to show up. And that's where inside this directory, I will see these two files. So in fact, let's give this a shot here. So I'm going to apply ConfigMap mount. And now if I exec into that, let's just do a shell. And if I go to /config, I'll see my two files there. And in case I actually renamed one of these in my example, I'll look at the YAML document again in just a second. So the user interface properties, well, let's take a look at that. Color.bad is yellow. And I could look at the rename properties as well. So again, that config map had all these contents in it, and I created this volume, this little USB drive, and I kind of plugged it into the container, and now it's available. And my app, in this case, I'm not really running an app, but my app could read these properties files and now reconfigure itself to, in this case, all right, the good color is purple and the bad color is yellow. Okay, so again, config maps are pretty flexible, right? Now, so let's talk about secrets. Secrets look and feel very similar to config maps. There's only just a few small little changes. Okay, so secrets provide the ability to store confidential data. Okay, so you're going to want to use secrets to store anything that needs protection, so like API keys or database credentials, or really anything that should be protected. Okay, just as config maps, they leverage a data key and then key value pairs. The only difference is that the value is base64 encoded. Now, for those of you that know anything about base64 encoding, base64 encoding is not a way to really protect data, because you can easily base64 decode it. It's not encrypted. So don't think that, okay, looking at this, it's protected at all, because it's not. The reason why config maps and secrets use different formats is because, well, they were developed at different times, and one group decided to use base64 encoding, and the other one decided not to, and just kind of worked out this way. Also, secrets a lot of times will have non-string data. So for example, you might have a private key that's actually in binary format, and so the only way to store that as a string is to base64 encode it. So they kind of just took the universal, just base64 encode everything, and then we can treat everything as strings, and then the application can decode it and do something with it from there. Okay. So again, don't think that this is any sort of encryption or protection. And yeah, there's also several different types of secrets. So this is what's called an opaque secret. So it's just key value pairs. But there are other secrets that let you store, like what's my Docker credentials to pull images from a remote registry, or one that needs authentication, that kind of stuff. So now, just like in config maps, I can create files from secrets as well. The only difference is that the volume looks a little different. So now this little USB drive, again, that I talked about for config maps, instead of populating it from a config map, I'm going to populate it from a secret. And so in this case, I'm going to say secret name is sample secret. And in this case, what I don't have are, going back to the config map, I don't have a list of items. I can certainly still give it a list of items. Okay, I just want these particular attributes. But when I don't list the items, what it's going to do is for every key, it's going to make another a file with the contents. Okay, and one last thing to mention is all secret volumes use tempfs. And if you're not familiar with tempfs, it basically is a volume type that keeps all the files in memory. So these files will never touch the disk. They'll stay in memory. Now, let's go to our terminal, and I'm going to apply my secret. and I can get secrets, and I'll see that there's a couple different secrets here. We'll talk about service account stuff when we talk about RBAC, so just kind of ignore that one for now. And this Vault Verifier token, that's just another service account for a demo that I'm doing for some other stuff. But I see this opaque secret here, named sample secret, and I can actually get the secret. And if I take this, I can actually echo that. Base 64. Let's see, I'm on the Mac, so I think I have to do it with a capital D. Yep. And so my my password is super secret, and the username, let's see what that is. Okay, it's a fancy username. Okay, so again, the secrets are here, but if I get them in YAML format, I can still see the original values for them. So again, remember they're not sitting encrypted, they're not protected. Now the cluster itself is going to store them encrypted, and again that's going to require, if you're setting up your own cluster, you'll have to do some configuration to set that up. And I'm not going to go into that today. But anyways, we'll talk about how to further protect secrets when we talk about RBAC. Okay. Yeah. So let's now apply secret pod, and if I exec into that pod, if I go to /secrets, I'll see both password and username, and I can cat password, I can cat username, and I see those values. So I see the fancy username, and I guess it covered up my password because it didn't have a new line at the end of it, but whatever. And there we go. And if I, just for kicks, I know most of you won't care or whatnot. Oops, grep for secret. I'll see that the /secrets is a tempfs mount point, and it's mounted as read only, so I can't make changes to any of the secrets, obviously. Okay, so that's more or less how secrets and config maps and all that kind of stuff work, and how I can make those available to my applications as they're running. Okay. One last thing, and I'll do a demo of this, is when I make changes to a config map, all the pods that are using that will get the updated values. Okay. The change may not happen immediately because obviously it needs to kind of propagate a little bit, but you'll see that the files will get the updated values. And again, we'll try this out in a demo here in just a second. But some applications kind of read their config when they start up, and that's their configuration from that point on. And so even if the file changes, it's up to the application to read the new configuration and reconfigure itself. Some applications can reconfigure themselves. Others, once they're configured, can't change. So one of the things that you can do is you can use other tools, and this is one that we actually use quite a bit. So Staccator, the reloader. And what this does is allows you to annotate, and we'll talk about annotations again in just a little bit in a future lecture. I can annotate my pods or my deployments so that anytime my config map changes, it'll automatically restart those. So again, I've got an application that reads its configuration when it starts up. If the config map changes, it'll automatically bounce all those pods, and then they'll start up, they'll read the new configuration and go from there. So let's actually take a look at this here. So let's see what pods I have running. All right, so let's go back to this one here. Oops. Have to give it a command to run. And okay, so let's look at our user interface properties. And now let's make a change to the config map. Game demo. And let's change the user. Let's see, let's pick a color. I really like blue, so let's make the good color blue. Okay, so it says that the config map has been edited. If I look at the config map, I should see the updates there. I'll scroll up here. Yep, it's definitely been applied there. And now if I go to the container, so it still says purple now. So again, it takes it a little bit for it to kind of propagate these updates. Let's see, it's watching here. Yeah, I can. Okay, and we'll see how long it takes to update this. All right, while it's doing that, let's oh, there it goes. So it just got the update. And yeah, I don't know how often if the kubelet's polling every 15 seconds or something like that. I don't know how often it gets it, but anyways, um, it's got the update and it can then um, reload the properties and kind of go from there. So anyways, so to wrap up, this week's hands-on, we're going to do some kind of gentle introduction to use environment variables, config maps, and secrets. And then we're also going to try a couple different challenge problems. So I'm going to give you a couple specific things. Okay, now that you've had a little bit of introduction, go and try doing this and see what you can do. There's actually been some pretty cool um, projects or things that I've seen that, if you think about it, config maps can be overlaid anywhere within a container. And so what I've seen is um, some projects will say, all right, we've got this website that's fully containerized or whatnot. And if you want to change the style sheets, for example, create a CSS style sheet and mounts it over the existing one that's in the application. And so when the container starts up, it sees the overridden version that's been mounted on top of the old one. And so then the users that hit that application will see the updated version with your overrides and changes in it. So, and it's theoretically possible to just ship an Nginx container and provide the index.html as a config map and kind of use an off-the-shelf just plain Nginx, but then your site itself is coming through config map. So there's some pretty cool things you can do. Whether you should or not, that's a whole nother question. But yeah, config maps are pretty powerful. And this ability to kind of layer in files and configuration and change our applications is pretty awesome. So anyways, enjoy the hands-on this week. And if you've got any questions, feel free to reach out to me and we'll go from there. Thanks all.